Good afternoon. So we are ready to now put the polynomials that we've been factoring into equations. So we're going to put our polys and put them into equations. And then why do we do that? Well, usually when we put things into equations, we put them in so we can solve for the variable. So now we're going to actually solve for x, y, or whatever the variable is. But first we need to rely on something we proved way back in Unit 2, and that is this fact. For any real number x, this is true. X times 0 is 0. Okay? You've known that for a long time. We proved it in Unit 2, and we're going to use it a lot right now. So based on this universal fact, we can draw some conclusions. If a times b equals 0, then what can we say about a and b? We can say that a equals 0 or b equals 0, right? One of them, at least one of them, has to be 0. If a times b times c equals 0, then a equals 0 or b equals 0 or c equals 0, okay? And of course, if a, b, c, d equals 0, this is just a quick way of writing a times b times c times d, then it must be true that either a equals 0 or b equals 0 or c equals 0 or d equals 0. Okay, so these three conclusions are based on that. And we're going to use these conclusions over and over and over again today as we factor polynomials and solve equations by factoring. So here's a polynomial in an equation. So x squared plus 5x plus 6, we probably actually factored this before in our homework the last 2 days. I am now putting it on the left side of this equation, and on the other side of the equation, I have 0. So when you see a quadratic trinomial, quadratic means degree 2, trinomial in an equation, and the other side is 0, always factor the polynomial if possible. So when I find the winners, 3 and 2, that allows me to go straight to the factored form, x plus 3 times x plus 2. And that product equals 0. Okay, so now when we're factoring, you've got to remember we're actually in an equation now. So you need to copy the equal sign and then copy down the 0. Okay, we're in equation solving mode. Okay, now here's where we use our little factoid. Anything times 0 is 0. So think of x plus 3 as a, and think of x plus 2 as b. So this is no different than saying a times b equals 0. And the conclusion is, if a times b equals 0, then a equals 0 or b equals 0. So in this situation, x plus 3 equals 0 or x plus 2 equals 0. One of those, at least one of those must be true, right? Okay, so if we say that x plus 3 equals 0, then that means x must equal -3. We just solved this equation independently. And if x plus 2 equals 0, then x is negative 2. So there are two solutions for x here, negative 3 or negative 2. So you can write your answer like this, or you can write it as a set, negative 3 comma negative 2 in the curly braces, like we did way back in Unit 1, set theory. Okay, so you can write it either like this or like this. Okay, so to sum up, we have our polynomial on one side of the equation with the other side being 0. We factor the polynomial. For each factor, we set it equal to 0, and then we solve each little equation separately. Okay, let's try this again. Okay, again I have my quadratic trinomial on the left, on the right 0, so I factor. The winners are 9 and negative 4. Now I imagine x plus 9 is 0. I also imagine if x minus 4 is 0. In this case, x is negative 9. In this case, x is 4. So that's my those are my two solutions, or if you prefer in solution set form, negative 9 and 4. Okay, but sometimes when you factor something, you don't just have two factors, right? In this case, we will have more than two factors. Remember, in our factoring checklist, the first thing you should do is take out the GCF. GCF here is x. Left over, x squared plus 3x minus 40. Okay, this is a trinomial that can be factored. If we play the game, the winners are 8 and negative 5. So the factors are x plus 8 and x minus 5. How many factors do you see? There are 3. 1, 2, 3. So it is possible that this factor is 0, or this factor is 0, or this factor is 0. Just like up here. If A, B, C equals 0, then A is 0, or B is 0, or C is 0. We must consider all three possibilities. So if the first factor, x, is 0, then, surprise, x is 0. If x plus 8 is 0, then x is negative 8. If x minus 5 is 0, then x is 5. So our solution set is 0, negative 8, and 5. Okay, this doesn't only work for trinomials, it also works for binomials. So if you take a simple difference of squares binomial and factor it, you will also get two solutions. If x plus 5 is 0, then x is negative 5. If x minus 5 is 0, x is positive 5. So the solution set is plus or minus 5. You could also get solutions from factoring if you're given a binomial that is not a difference of squares. A binomial that just has GCF, like this one. X squared minus 7x is 0. I look at this binomial, it is not a difference of squares or difference of cubes or sum of cubes, so the only thing I can do is take out a GCF. And again, I will have two solutions because this is the first factor If x is 0, then guess what? X is 0. If x minus 7 is 0, then x is positive 7. So my solution set is 0, 0, and 7. Okay, now these 5 examples, or 5 examples, I would consider level 1 as far as on the easy scale, because they all had something in common that made factoring very easy, and that is, and I'm not talking about a equals 1, although that did help. I'm talking about the right side of each equation was 0. It's not the case that every time you're given a degree 2 quadratic equation that the right side is 0. It is very important that the right side is 0, because if the right side is not 0, you can't conclude that a equals 0 or b equals 0. If it says a times b equals 5, can you say that a is 0? No. Can you say that b is 0? No. If a times b equals 5, a and b could be lots of different things. You have so many possibilities. So it's very important that the right side is 0. Having said that, I also said that the right side sometimes is not 0. So then what do you do? In this case, for example, x squared minus 4x equals 21. Now, if you just focus on the binomial on the left, you might think, oh, I see a GCF. I better take it out first, because Mr. Huang told me, first step in factoring, take out the GCF. That is true. If all you were asked to do is factor x squared minus 4x, I would recommend you take the x out first. However, it's part of an equation now, so you have to consider other things. The first priority is make right side 0. You must make the right side 0, because, as we saw before, if you don't make the right side 0, we can't use any of these facts to draw these conclusions. Okay, no problem. If I want to make the right side 0, I'm just going to subtract 21 from both sides. It only takes one step. Okay, the right side is 0. Now, if this is a solvable equation by factoring, then this polynomial should be factorable, and it is. The winners are -7 and +3. Okay, if x minus 7 is 0, x is 7. If x plus 3 is 0, x is -3. So my solution set is 7 and -3. So when the equation has a non-zero number on one side, it's an easy fix. You just subtract that number from that side to get it over here. So it's only one extra step to do when the other side is not 0. Okay, here's another example of that. Okay, right side is not 0, so to make it 0, I subtract 5 from both sides. Right side is now 0. Now I play the game. Winners are 2 and 1. and my solutions are -2 and -1. Okay, so that is your introduction to solving equations by factoring. Remember, first priority makes right side 0. Once that's done, then factor your polynomial, and for each factor you should have a solution. Okay, see you next time.